All right, just a quick video to show you what's on the lab sheet while I was doing the lab. All right, on the first one we said we had hung a heavy weight over here, and so that's the resistance force, and it was 10.0 newtons. And let me change that color to something a little more visible. There we go. Okay, and the resistance distance we said was 10 centimeters, which is 0.100. Whoops, hang on. For some reason it's not wanting to do that again. All right, so that would be 0.100 meters. Okay, 100 thousandths or a tenth of a meter. All right, so that would be that. All right. Now on the other side we hung a 10 Newton weight also, so it's going to be 10.0 newtons. For some reason my writing thing's not working very good today, but anyhow, 10.0 newtons also. All right, we had an equal weight over here, and that distance ended up being 59.7 minus 49.6. Okay, if you remember correctly, our midpoint was 49.6. Okay, and so when I put the other weight on it, it was 59.7. Okay, minus that one, and if you subtract those, you actually get, unlike what I said in the video, instead of, you would get 10.1 centimeters, and if we change that to meters, we'd move it over twice, and that would be 0.10. And here we go again. Okay, 0.101 meters. Okay, now to get the torque, you would multiply this times this, and you get that, and this times this, and you get that. All right, now on the second one, we still had the same one we had up here. Let me copy it. Okay, let's see if I can copy it. But we're going to have the same thing down here, because, so for the second row, I'm just going to drag these down rather than type them in again. All right, and this time, instead of having a 10 Newton weight, we had a 5.0 Newton weight. All right, and our distance was, I believe, this time 69.1. So if we go up here, we're going to say that's 69.1 minus 49.6. All right, if you will subtract those and then move the decimal two places, that's your answer that will go there. All right, and the last one that we did, we had a 5.0, sorry, click back on the text box again. Okay, we had a 5.0 Newton on this side. Sorry, get it in the right spot eventually here. And we had a 2.0 Newton on this side. This one was still going to be 0.100 meters from the edge. All right, this one, however, was 72.9. Okay, try one more time. Okay. All right, here we go. 72.9 minus 49.6. Okay, so you subtract those two, move the decimal over two places, and that will be the number of meters that go there. All right, then to get the resistance torque, for our notes yesterday, we said the resistance force times the resistance arm, and this should be arm. I apologize for that, but that is bad. That should say arm, and it does not. Okay. All right. Anyway, that should be resistance arm, not resistance distance. I apologize for that. And this one should be effort arm, not. Yeah, that's kind of bad, but okay. Let me just put what it should be here. This should be the effort arm, and this one. Oh, sorry, this should be the resistance arm. My bad. All right, maybe I should just go to bed, get back up, try this again. Okay, here we go. Resistance arm. That's because I think I spelled that right. It looks a little odd somehow, and this one over here should be the effort arm. Okay, and basically, if you multiply the resistance force times resistance arm, it gives you resistance torque. Okay, effort force times effort arm will give you the effort torque. All right. Okay, so there you go. There's that. And once you multiply these two to get your three answers here and your three answers here, then you can compare them. And that should tell you enough to answer about the relationship between the resistance torque and the effort torque of a balanced first-class lever. So if you'll answer question number 1 and fill out data table number 1, except for the bottom blank, which is an extra row. All right, that should do it. Thank you a lot. Have a good day.